Today we're going to talk about how to install a heat bed on the Big Tree Tech SKR Pro version 1.2. Now I need to explain a couple of things that may not be clear in how to do this. So I'm going to start with the terminals for power. So over here we have our board-in power for the heat bed. Then we have our power out for the heat bed. And as you can see, I marked red for the terminals that have voltage and no mark for the ground lead. Now keep in mind that for the heat bed, you don't have to worry about positive and negative for the out power. But we also have our leads over here for our board logic. And then we have the leads over here for our steppers. So it's the stepper logic ports or motor power. Then we have over here our thermistors that I need to talk about. So there's 4 of them. According to the diagram, it says for the pinout diagram that this is T0, T1, T2, and T3. So it can be kind of confusing. So what I'm going to do is actually show you the manual. So if we go over to my desktop for a moment, you can see that I have the Big Tree Tech website open for GitHub over here. And then we have our manual that'll be in the SKR Pro folder. And then of course there's the SKR Pro folder for 1.2 in here. And what I've done is I've already opened up the tab in the manual to where it outlines what the actual thermistors say. So we see that T0 is actually the bed. Then we have E0, E1, and E2. Those would be your extruders. So the reason that I'm covering this is so you can see what they are. They're also in the actual configuration for VScode. So I'm going to show you how to open this up and set it up in just a moment. But first I'm going to show you how to configure the board real quick. So over here on the board, what I'm going to do is I'm going to actually grab the lead that would be for the thermistor. Now I've tacked on a wire here so that I can have a little connector. And positive and negative don't matter in this case because it's judging the heat by the actual power running through a glass bead right here. And what that means is how long the power takes to travel from point A to point B through the glass bead is what your temperature is, because that allegedly is proportional to the temperature at which it's operating. So now that we have that set up, I'm actually going to connect the leads over here for the positive and negative power. Now obviously the thermistor, or excuse me, the heat bed doesn't care about the actual polarity in this case. There are other cases where it may matter, and that's if you're using something like a relay from another power supply. But we're not going to go into that right now. I'm just showing you the basic setup. So in this case, I'm going to be running with 12 volts of power. So I'm going to put this down over here just so we can keep an eye on it. And then I'm going to connect the actual power leads to the board. So over here, I'm going to connect the actual positive lead for the board logic. This would be voltage. And then I'm going to connect the negative lead, which is ground in this case. And I got to make sure that I actually connect it right because I'm connecting it the wrong spot. So I'm going to slide that over a little. It's actually over here. So that's there, and this is over here. So that's the board logic. Now we're going to do the actual heat bed. In this case, my power supply is actually 12 volts. So I'm going to connect this right here. And then I'm going to connect the ground lead over here. Let me loosen this up a little here. There we go. And I'll tighten that down. And for safety, I like to close this down so that I don't accidentally touch anything. So now that we've got that connected, next thing I'm going to do is actually move this over a little bit. And then I'm going to actually pop out the drive right here. And I'm going to place it in here so we can load the software or firmware in just a moment. So I'm going to plug this into the computer. You may hear a beep. And now I'm going to go over to VScode. Inside VScode, I've already downloaded and extracted the current version of Marlin. And that version is 2.0.9.1. These may change over time, just keep that in mind when watching the tutorial. So I'm going to click on here for the Explorer, then Open Folder, then I'm going to go to my Downloads folder, and my Marlin folder that I extracted, then the next Marlin folder, then Select Folder. Now that this is open, what we need to do is configure the board, because currently it's set for the Mega 2560, which is the ramps configuration, which is the normal default configuration that they use. So we need to find ours. And so in order to do that, we're going to start with the Marlin folder, then the source folder, then the core folder, then we're going to go to boards.h. Inside here, we're going to search on SKR Pro. And as you can see, there's two Pro boards. The one that we're working with is the 1.2, so I'm going to copy that. Then I'm going to close out of boards.h. I'm then going to minimize this in just a second, but I have to show you one more quick thing here. Over here, they have the actual chipset type, which is STM32F4. That's going to be important in a moment, and I'll show you why. But before I do that, I'm actually going to show you the pins so you can see what's going on. So down here, they outline where the thermistor is in the folder for STM32F. So if we go over here and we look for the SKR Pro version 1.2 for the pins file, we can open that up, and right here it's referring to another file. That's a way of including information about the pins. It's actually added on when it's compiled. So we have to go to the common folder, and in the common folder they have the pins outlined, or a database of pins in a file. So what we're looking for is the actual extruder, or excuse me, heat bed, pardon me. So we're going to search on heat bed and see if we can find it. We don't find anything, so let's look for a hot end. So we see hot ends here, and then we see pins. So these pins are actually for the actual heating of the hot end or the probe sensor. So you see PF10. So if we go over to the browser for a moment, we can actually go to the pins file and we can see what these are. So down here, if we wanted to see how they correlate, we know that T0 is PF3. So let's try searching on that to see if that will get us to where we need to go. So we'll search on PF3. So what it says here is temp bed. So we know that that's the actual pin that we're connected to. Sorry for the sidetrack, but I just wanted to make this clear. In case you need to modify this in the future, you understand how you can do it. So I'm going to close the pins file for a second. Now I'm going to go over to boards.h, or excuse me, configuration.h, and I'm going to search on motherboard. And here I'm going to highlight the ramps configuration and paste what we copied earlier. Then I'm going to scroll up and change the serial port to -1. That's so we can communicate via USB. And then I'm going to search on thermal or thermistor, which is thermal settings. So down here we have different types of actual thermistors that we can choose from in a list. I'm going to use the number 8 for what we're working with. So you can always look up what your type is, but I always go with 8 in my case. So I'm going to scroll down here and I'm going to search for the actual bed sensor. So here I have to say that it's 8 instead of 0. That way it says that it's populated, just like it would be for your first thermistor. Now that that's said, I just need to show you one last thing, and it has to do with thermal runaway. Obviously there's stuff up here about PID settings, but I'm not going to cover that right now because it's an advanced tutorial. It's a way to tune your actual heat bed. But down here we have the actual settings for thermal runaway protection. Excuse me. And what I want to tell you about this is do not change it. What will happen if you change this is that you could cause a fire. If your thermistor fails, what'll happen is it'll automatically disable the power to your heat bed, thus turning it off so you don't have a fire. So always leave these settings alone for your safety. Also, always keep an eye on your printer when you're printing. So, now that we've got that covered, I'm going to set up how to actually do the build. So I'm going to go over to the INI folder, and inside here we need to find the INI that's for our board type so we can populate platform IO for the default environment. So as you can see in here, there's an STM32F. So we're going to go in here and we're going to search on SKR Pro, and we're just going to copy this right here. And then we're going to go back over to platformio.ini, paste it right here. And then what we're going to do is click on the little garbage can over here to clean out the actual .pio folder because it has the remnants of the Mega 2560 that was built before it was uploaded. So I'm going to click on the little garbage can for clean. And what will happen is it'll clean out the contents of this folder. So as you can see, there's no longer a Mega 2560 in the folder. So now we're going to do a build by clicking on the checkbox, and this folder will not populate with the actual information from our build. If you encounter an error while it's building, click on the actual checkbox again, because sometimes things build out of order and that might resolve your problem. If it fails that time afterwards, then find the very first error in here and correct it, because the other errors might be a cascade of errors caused by the actual situation where the build didn't complete with the first error. So now that it's done, you can see down in here that there's a firmware.bin. I'm going to right click on that and I'm going to say reveal in File Explorer. Inside File Explorer, I'll make this a little bit bigger so you can see it. You can see that there's a firmware.bin. Over here, we have the previous drive for the USB that was on the SKR Pro. So this was originally firmware.bin and got renamed to firmware.cur in all capital letters. That way it wouldn't load a second time. And for those that don't understand, it's actually not a cursor file. It's just a way to mark it so it does not reload. So I'm going to go back over here and right click, and I'm going to say send to the E drive. Once that's complete, we're actually going to double check to make sure it's there, which it is. And then we're going to go over to the workbench and pop out the actual drive. And then I'm going to insert it inside of here. Once that's inserted, we're going to connect the actual USB cable in order to load the firmware. Now there's two ways to do it. First way is actually to connect to the actual drive and use the 5 volts to do it. And the other way is actually to use the direct power that you would receive from your actual power supply over here. So if I open this up, you can see that we're wired up okay. Everything matches the colors according to the pin out diagram. So what I've got to do now is actually find the cable for the USB, and also show you that this jumper over here, if you move it over to here, you'll be using direct power. That's what you want to use when actually using it. But to load the firmware, I'm going to move it over here for the moment just to show you. So I'm going to connect it here. It'll load the firmware. You'll see a flashing light. And you should hear a beep, which means it's now connected to your computer. So I'm going to disconnect this for a second. Move this over here so you can see the actual difference. Now you see a light but nothing loading. That means it's running off direct power now. So in order to do that, I need to plug it in. So once this is plugged in, the system is energized, so do not touch the board. So I've got that plugged in. Now I'm going to go over to Pronterface and actually test this out. So inside Pronterface, we have one issue. Right now it says COM port 1. So we need to fix that real quick to figure out what COM port to connect to. So I'm going to go over to my desktop for a second, type in Device Manager, and when that comes up, we can actually see what the actual COM port is. So in this case, I'm going to expand this out, and because it's a desktop, COM port 1 is default, but COM port 13 in this case is our board. So I'm going to minimize this. Then I'm going to go over to Pronterface and I'm going to change the 1 to 13. Then I'm going to say connect. So now it says connecting. Printer is now online. So in order to actually use the Heatbed, what we're going to do is we're actually going to set the temperature in this case. So I'm going to say we're going to set it to 50 degrees Celsius. Then I'm going to click on the set. And you'll see over here that the temperature will be tracked. So I'll click here and you can see that it's set. Now if an error occurs and it doesn't work and you see something over here, it's probably due to the thermistor malfunctioning, which means that it's either a broken wire or it's not seated correctly in the actual connection on the board. So we're watching it now and you can see the temperature is slightly rising. And then in here, it actually gives you an actual readout of what the bed temperature is. So it's 18, 19 degrees Celsius approximately, now 20. So to test this, we can also use an actual heat sensor. So I'm going to try it and see if it works. So it says 58 degrees and up there it says that it's 28, 30 degrees, so I might have this set to Fahrenheit. So let me try that again. So now I'm on Celsius, and it says 64. So apparently I'm not getting a good read on this, which is okay because there might be a difference between the actual temperature, but it's so cold. Well, actually you can feel the heat in this case, but it's only approximately 41 degrees Celsius. So it is tracking correctly, it's just my heat sensor is not working correctly. So if you like my tutorial, please hit the like button and subscribe. And for those that want to see tutorials early, I will place them on Patreon so you can view them if you choose to there. And I also have to thank the people that also tip on PayPal. It's greatly appreciated and helps offset my expenses to make these tutorials. So everyone take care, have a nice day, and I'll catch up with you later.